So, continuing with our discussion on free energy, let us dig a little bit deeper into it. Free energy is generally represented by G, and the mathematical equation which express free energy is represented by delta G is equal to delta H minus T delta S, where delta G represents the change in free energy, delta H represents the change in enthalpy of the system, and delta S is representing the change in the entropy, while T here is the absolute temperature. If the value of delta G from any chemical reaction, or more accurately a biological reaction, if the value of delta G is negative, we would say the reaction is occurring on its own. In other words, the reaction is spontaneous. But you cannot understand delta G without understanding the other two terms which I have just used, that is the enthalpy and entropy. The enthalpy, or more accurately the change in enthalpy, refers to the heat content of the reactant system, from where that heat comes, by the way, or from where the energy of entropy of enthalpy comes. If you see any system which is made up of chemical reactions, the chemical reactions are arising from the molecules, and molecules have bonds, chemical bond between them, and the energy contained in these bonds give rise to the enthalpy. So, the enthalpy has its origin in the chemical bonds which are present between the molecules. That is why we say internal energy, because of internal arrangement of molecules also. So, if in a reaction the delta H is negative, the reaction will be exothermic, because it is releasing energy. You can see it is releasing the energy, it is a spontaneous reaction. On the other hand, if the delta H is positive, the reaction will be absorbing energy and it will be endothermic, it is absorbing. So, that is why, because it is taking the energy, that is why it is positive, and the reaction will be non spontaneous. Then let us move to the next term, a very vague term, little bit difficult for the students to understand, but let me tell you, it is a very important and very interesting term, that is entropy. Entropy refers to the randomness or disorder of a system. If you can see this animation, things are moving from very simple organized things to very complex arrangement. There is a disorder which is going on increasing, and that is entropy. If entropy is positive, the reaction will be spontaneous. If the entropy is negative, the reaction will be non spontaneous. So, the value of delta G depends upon both entropy and enthalpy. Neither one of these can determine whether or not reaction will be spontaneous. You have to take into account both entropy and enthalpy. So, whatever chemical reaction, for example, as simple as the formation of sodium chloride, or as complex as which are occurring in our body, this equation is universal in our understanding of the dynamics of energy changes in our delta G is equal to delta H minus G delta. So, now some food for thought. जब तक आप अपने आप से सवाल नहीं करेंगे, आप साइंस नहीं समझ सकेंगे. You must ask questions, and first question should be that what is meant by free in this convention of free energy? Why don't we say simple energy? Why free? What does this mean? Second, if the work depends upon heat content, then why we introduce the entropy concept? Why we can't simply say that if only if we add the work in this equation, and we say that if the work is, I mean, if the heat is being released, then as a result of this the reaction is exothermic and spontaneous, then why we have to add the entropy concept? Then to answer this question, I am going to give you a hint, and that's another question. Is melting of ice exothermic? Do you think so? If it's not exothermic, but isn't it really spontaneous? So, if you relate this question with the previous question and really think a little bit deeply, maybe you will find the answer. And this is how we move forward in science, asking questions. What is the use of temperature term? I didn't speak much on this temperature term. I wanted you guys to think a little bit about it. What is the use of the temperature term in this whole equation of the free energy, which is relating free energy with the entropy and enthalpy? And then last, why spontaneity arise from negative value of g? I mean, what if the value of g was positive? Why couldn't be spontaneous then? Why reaction couldn't be spontaneous? Why it has to be negative g value for a reaction to be spontaneous? These are the questions you should ask yourself.